Good day, everyone. I'm Ma'am Bustrilius, your teacher for the subject General Mathematics, and today I will discuss about conditional propositions. Let's go! Now let me explain to you all the structures of conditional propositions. Let's start with antecedent, or known as P. It is the hypothesis or condition. Consequent, or known as Q. It is the conclusion or result from the hypothesis. Symbol, or known as arrow, it is representing the if-then relationship. Condition, it is in the form of if P, then Q, when the P is the antecedent and Q is the consequent. For conditional propositions, the symbol arrow is used. For its truth value, it is true except in the case where P is true and Q is false. It is where the antecedent is true and the consequent is false.
What are the different forms of conditional proposition? These are the following. We have converse, we have the inverse, and contrapositive. So for the converse of a conditional, P implies Q. It is just done by switching the positions of the propositions. So from P implies Q, the converse is Q implies P. That means to say that the antecedent P in the conditional becomes the consequent in its converse. Similarly, the consequent in the conditional becomes the antecedent in its converse. For the inverse of a conditional, you just have to negate the two propositions. So from P implies Q, you'll make it as not P implies not Q. So basically, you just have to negate two propositions, and how to negate it? Just have to add the word not in the statement. So let's proceed with the contrapositive of a conditional. P implies Q. So this is it. Not Q implies not P. So you switch the position of the two propositions and negate it afterwards, like this. So this is the converse, inverse, and contrapositive of a conditional proposition. These three are its related implications. Note: P implies Q is to not Q implies not P. Condition is logically equivalent with its contrapositive. So the left one is the conditional form and the right one is the contrapositive form. Q implies P is to not P implies not Q. Its converse is logically equivalent with its inverse. And similarly, its converse Q implies P is logically equivalent with its inverse. Not P implies not Q. Is there something that can prove the equivalence of conditional and contrapositive, and the converse and its inverse? Yes, there is. When you construct the truth table of the conditional and contrapositive, and similarly with its converse and its inverse, you will see that the truth values for the conditional is the same with its contrapositive, and of course, the truth table of its converse is also similar or equivalent with its inverse. That's why the conditional is equivalent with contrapositive, and the converse is also equivalent with the inverse. Now let's have an illustrative example. P implies Q. If two angles from a linear pair, then they are supplementary. This is the form of a conditional statement. With the if-then statement, if P, then Q. The proposition P is two angles form a linear pair, while the proposition Q is they are supplementary. To find the converse Q implies P, you just have to switch P and Q. Therefore, if two angles are supplementary, so this is our Q, then they form a linear pair is our P. So what about our inverse? Not P implies not Q. If two angles do not form a linear pair, then they are not supplementary. So the same position, but you just have to negate both propositions. So for the proposition P, you add the words do not, while for proposition Q, you add the word not. This is the inverse of the conditional. Let's move on with its contrapositive. So for contrapositive of a conditional, follow this format. Not Q implies not P. So we have, if two angles are not supplementary, then they do not form a linear pair. So for our Q, here they are supplementary. But since this is negated, we add a word not. And for our second proposition, which is not P, they do not form a linear pair. So still, we add a word do not to negate the proposition P.
So here's the example number 2. So this is our conditional. If it rains tomorrow, then the school trip will be postponed. Let's proceed with the converse, where Q implies P. If the school trip is postponed, then it rained tomorrow. That is the statement for converse. Now let's proceed to the inverse, where not P implies not Q. So this is the inverse statement. If it does not rain tomorrow, then the school trip will not be postponed. So that is the inverse statement. Let's proceed to the contrapositive, where not Q implies to not P. So this is the contrapositive statement. If the school trip is not postponed, then it did not rain tomorrow. So these are the example number 2. So let's proceed to our example number 3. So our conditional statement is if carbon emissions continue to rise, then global temperatures will increase. So keep in mind that is our conditional statement. So for the converse, Q implies P. If global temperatures increase, then carbon emissions continue to rise. That is our converse statement. Now let's proceed to inverse, where not P implies not Q. So this is our inverse statement. If carbon emissions do not continue to rise, then global temperatures will not increase. So that is our inverse statement. Now let's proceed to contrapositive statement, where not Q implies not P. So the statement is, if global temperatures do not increase, then carbon emissions do not continue to rise. That is our contrapositive statement.
Let's have another example. So our conditional statement is, if a student studies regularly, then they will pass the exam. So that is our conditional statement. Our converse, where Q implies P, our statement is, if a student passes the exam, then they study regularly. That is our converse statement. Now let's proceed to inverse, where not P implies to not Q. Our statement is, if a student does not study regularly, then they will not pass the exam. That is our inverse statement. Lastly, contrapositive, where not Q implies to not P. Our statement is, if a student does not pass the exam, then they did not study regularly. That is our contrapositive statement. Now let's have our last example. Our conditional statement is, if a triangle has 3 sides, then it is an equilateral triangle. So for the converse, where Q implies P, our statement is, if a triangle is equilateral, then it has 3 equal sides. That is our converse statement. Now let's have the inverse, where not P implies to not Q. Our statement is, if a triangle does not have 3 equal sides, then it is not equilateral. That is our inverse statement. Lastly, our contrapositive, where not Q implies to not P. Our statement is, If a triangle is not equilateral, then it does not have three equal sides. Recalling of answers. So now, let's recall the answers that we had earlier. This is our conditional. P implies Q. If two angles form a linear pair, then they are supplementary. For its converse, follow this format. Q implies P. If two angles are supplementary, then they form a linear pair. For its inverse, if two angles do not form a linear pair, then they are not supplementary. So the inverse is not P implies not Q. For its contrapositive, if two angles are not supplementary, then they do not form a linear pair. And of course, the converse and inverse, if two angles are supplementary, then they form a linear pair, is logically equivalent. If two angles do not form a linear pair, then they are not supplementary. My dear students, to find the different forms of conditional propositions, you just have to follow the format for converse, inverse, and contrapositive. Now this is the end of our topic. This is Ma'am Australia's, your general mathematics teacher, saying goodbye and see you next time.